Okay, let's start off this course by talking about some symbols that you're going to be dealing with. Now, for those of you who've had prior courses, you will remember that we did a lot with low voltage and low voltage controls. Refrigeration is a little bit different. There are no low voltage controls. Okay, in other words, everything you're going to deal with is either 120 volts, 240, 470, 408, 208, depending on the circumstance. Most of our equipment in the shop is going to be 120 volts. So for the moment, I want you to ignore the low voltage that you've learned about in other courses, or for those of you who are new, we might not have ever touched low voltage. So everything is going to be sort of based on your line voltage, which is basically what comes out of your wall outlets. So that's where we need to start. Okay, now everything that you look at on a schematic diagram, which is a diagram of a circuit, has symbols. Okay, in your books and on your course page on Moodle, there are some symbols as well. You'll have a symbol sheet that's somewhat like this, that has the different symbols. These are very important to memorize. You really need to get these memorized by the end of the second week of class. So we're going to talk about a few of these. Okay, a switch is basically an open or closed device. When a switch is open, it does not allow electricity to flow. Okay, in other words, it's like in its top position. When it's closed, it allows electricity to flow. So it's exactly the opposite from a water tap. Okay, an open switch stops electricity from flowing. In other words, the light bulb is off. A closed switch starts electricity flowing. The light bulb comes on. In refrigeration, a closed switch would be like a thermostat that is in a space that's too warm. Okay, the thermostat is too warm, it closes, it turns on the compressor or the cooling circuit. When the space cools off, it opens, and thus you have an open switch, de-energizes the compressor. So I might as well introduce those two other terms while I'm at it. Energize and de-energize. Okay, de-energize means turned off. No energy is going to the device that we're running, which is the load. So no energy is going to a light bulb when it's de-energized, no energy is going to a motor when it's de-energized, and no energy is going to a compressor when it's de-energized. When it's energized, it means it's getting power. Okay? When something's energized, it's getting power. The light bulb is on, the motor's running, the cooling is running, so it's getting power. So a switch can either be a normally open, that's its default position is open, in other words shut off, or normally closed. Okay, so when we're talking normally open switch, we're talking the light switch on the side of the room. It's normally open because it's de-energized. Okay, normally we don't leave lights running all the time. Well, maybe some of you do, but normally we don't leave lights running all the time. Normally closed we use in cases of safety switches. They're normally closed through normal operating conditions. It's normally closed. Okay, in other words, the load has a path for electricity to flow, and if you look at it, there's a full path. We're talking about the path for electricity to flow. Push button switches. Okay, you push it in, it comes on. That's a normally open. You release it, it turns off, because that's the normal condition. Normally closed would be, it's normally a closed circuit. Okay, in other words, it normally has a path for electricity to flow. I push it in, it opens. Okay, the normally open would be like your refrigerator door switch. Okay, when the refrigerator door is closed, the light is not on. Okay, when you open the door, the light comes on. Okay, so normally closed. Push it in, it turns off. Door closed. Open it, it springs out, and you have the contacts made, and you have a path for electricity. Okay, for those of you who had the gas term or oil term last term, we had a normally open switch. It was on the blower compartment doors. Put the door on, the switch pushed in, it was closed. Pull the door off, the switch opened for a safety circuit. So normally open, normally closed push button switches. Okay, some of these come with sometimes we have indicator lights. Okay, you'll see an indicator light symbol with the color of the bulb inside the circle. So you have a light bulb with an R, an A, and a G. All it is, it could be an LED light, could be any type of light, but it serves as an indicator. Then we have relays and contacts. Okay, the most often one you're going to see is the one over here. That's that we call it just a relay. Okay, Mars relay. Okay, but inside of it we have a coil and we have contacts. Okay, your coil terminals are down at the bottom. They're by themselves. Okay, and if you look real closely, it doesn't show well on this diagram, but if you look real closely, from these terminals, there's a little wire that you can see that runs to the coil inside. Okay, then you have 6 contacts on most of them. You have one that's a common, which is 1 and 4. Then you have 1 and 2, which is a normally closed, and 4 and 5, which is a normally closed. Then 1 to 3 is a normally open, 4 to 6 is a normally open. And you'll have some of these diagrams in your shop projects. Okay, but what it does is basically when the coil is energized, it changes the position of those contacts. And if you look back here, you'll see how that works. Coil's energized, magnetism happens here, and it pulls the contact to its other position. When it's de-energized, it's in its normal position. So when I go back to this other slide, we have our coil, and then a normally open contact and a normally closed contact. Okay, so I power this thing. I power the coil. It creates magnetism. The normally open closes, and the normally closed opens. So you can see how that can be a switching device. We take a normally open, apply power to the coil, and then we go to a closed set of contacts. The normally closed does the exact opposite thing. You'll be using both normally open and normally closed in this term. Okay, the control relay is really designed to allow remote operation of equipment. Okay, it takes one set of amperages or power, and it actually operates another device. Okay, the relay consists of 2 portions. You have a coil, as I just showed you on that other slide, and you have a contact. And rarely you see the contact labeled as a switch like this. Most often the contact is labeled a little bit different. Okay, it has those sets of the parallel lines with the 2 lines coming out of it. Okay, the coil acts as a magnet, and when the coil is energized, okay, it builds up a magnetic force that attracts the control portion. You see how the force pulls that switch up and closes the switch. Okay, the coil of the control relay must energize before the associated contacts are closed. It is such a split-second thing, and this is how a coil would actually fall into a circuit. This S1 could be a thermostat, could be a pressure sensing device, could be anything. W could be a light bulb, or it could be a compressor, or it could be a fan motor. It can be anything that requires power. Okay, so you see how that built up magnet and the switch closes and energizes. In this case, we're using an indicator light. So probably the most important symbols that you're going to deal with this term is the switches, and there's various types of switches, the control relay, the contacts, and the motor.